Hello, welcome to this lesson. In this video, we are going to learn about the Lagrange interpolation. So let's look at what the Lagrange interpolation is about. So from my previous video, we learned about the direct method of what interpolation, where we had a general form of the polynomial function that we used to represent n plus 1 what data point. Okay, so same thing for this method also. So for this method also, we've been given a polynomial function which is the Lagrange interpolating polynomial. Okay, so Lagrange interpolation polynomial, which is given as the fn of x, which is equal to the sum of li of x multiplying with f of xi from I equals 0 to what n, where n in the fn of x stands for the nth order polynomial that approximates the function y equals what f of x, given at n plus 1 data point as x naught y naught x1 y1 all the way to xn minus 1 yn minus 1 xn yn, and then the li of x, which is a weighing function, is given as the product of x minus xj over xi minus what xj from j equals 0 to n, where j cannot be equal to what I. So look at what is happening here. So this is a general form of the Lagrangian interpolating polynomial. Okay, so what will happen is that if you are given the data point, all you have to do is to find the weighing function. Okay, so when you find the weighing function, you substitute it back into the general polynomial function that you have. Okay, so when you do that, you are going to have the general form of what the polynomial function. Okay, so let's look at how you are going to do this. So I'm going to use an example to explain this to you. So you know that the n there represents the order of what the polynomial that we are going to use for the interpolation. Okay, so let's say we are given two data points. Okay, let's say we are given two data points, and then you know that if you are given n plus 1 data point, then you are going to use what an nth order what polynomial, right? So in this case that you are given two data points, that means that we have what a 1 plus 1 data point, which is what which will give us the two data points. So in this case our n will be equal to what 1. So if you have two data points, and then that means that what our n is equal to 1, then we are going to use what a first order what polynomial. So using a first order polynomial and then relating it to the Lagrangian interpolation polynomial, we are going to have this to be f1 of x. Okay, and then this should be equal to the sum of what l. Okay, let's do it li of what x. Okay, multiplying what f of what xi. Okay, from I equals what 0 to what 1, because our n is what 1. Okay, so if you have something like this, we can write this as, we know the value of what I, right? Because I will be what I will be equal to 0 and then 1, right? So expanding this, you're going to have L naught of what x multiplying what f of what x naught, okay, plus L1 of what x multiplying what f of what x1. So this will be the first order polynomial function that you are going to use. In this case, that we have what two data points. So at this point, all you have to do is to find the weighing function. Okay, so let's look at that. So you're going to have two weighing functions here, which is what L naught of x and then L1 of what x, right? So let's write down the general form of the weighing function, which is Li, which is given as Li. Let me draw a line here. Okay, Li of x, okay, is equal to the product of x minus xj over xi minus what xj, where where j starts from what 0 and then n starts what n, right? Okay, so in this case our n is equal to 1. So let's write our general form. Okay, so you're going to have li of x, okay, to be equal to the product of x minus xj, okay, over xi minus what xj from j equals what 0 to what 1, because our n is 1. Okay, so now let's look at the possible values of j that we can have. J, okay, j can be equal to 0 and then 1. Okay, so we have what j to be what 0 and then 1. Okay, and then don't forget j, okay, must not be equal to what? I. Okay, j must not be equal to what? I. Let's take note of this. So now let's look at the first weighing function that you are going to have. That was L naught of what? X, right? So in this case, you can see that our I is equal to what? 0, right? And then the possible values of j will be 0 and then 1. And then j must not be equal to I, and then our I is 0. That means that this 0 is what? Is out. So now let's look at what you are going to have for L naught of X. So you're going to have just one j value, okay, which is what? 1. So you're going to have x minus what? X1, right, divided by x I, which is what? 0 now. So that what? X0 minus what? Sj, which is what? X1. So that would be the first L naught of what? X function. Okay, this is what you are going to have. So let's look at the second one also. So for the second one, we have what? L1 of what? X, right? So our j values will be 0 and then 1, right? And then our I is equal to what? 1. But j must not be equal to I. That's from the general formula. So j must not be equal to 1. So the only j value we have would be what? 0. So we're going to have Li of x to be equal to what? X minus what? Sj, and then our j is what? 0. That's the only possible value of j that we can have. So we're going to have x0 over what? Xi, our I is 1. So that's what? X1 minus what? Sj, which was x0. So this will be the second weighing function, okay, for this case. So now you have to substitute back into this general formula that we have here. Okay, so let me rewrite that. Okay, so rewriting that, okay, let me shift this so I can get some space. Okay, so rewriting it, okay, we are going to have we have uh we have f1 of x, okay, to be equal to L naught of x multiplying what? F of what? X naught plus L1 of what? X multiplying what? F of what? X1. Okay, so don't worry about the F of X naught and then the F of X1. They will be given to you in the question. Okay, so you know they come out of the data point, so you know what the F of X naught and then the F of what? X1 are. So now let's do the substitution. So we know what L naught of X is, right? That's what? X minus X1 over X naught minus what? X1, right? So this multiplying what? F of what? X naught, okay, plus L1 of what? X, which is now X minus what? X naught over X1 minus what? X naught, okay, multiplying what? F of what? X1. So this will be the first order polynomial that you are going to use. So for this polynomial, you know all the values. Okay, you're going to know f of what? X naught based on the data points you have, and then you know f of what? X1 also, and then you know x1, you know x naught also. The only value you will not know is the x, okay, which will be the value of x, which you want to use to find what? A particular what? Y. Okay, so that's what the Lagrange interpolation is about. So I want us to take an example so that we can understand this better. Okay, so I have this question here which says that the upward velocity of a rocket is given as a function of time in table 1. So this is the table. The question says that determine the value of velocity at what? Time t equals what? 16 seconds using a first order Lagrange interpolation. Okay, so a first order Lagrange interpolation means that our n is equal to what? 1, right? If our n is equal to 1, then how many data points are you going to have? You are going to have what? N plus 1 data points, which will be what? 1 plus 1 data points, which will be 2 data points. So now that you have 2 data points, that means that we are going to have our general form of the Lagrange interpolation function to be, let me write the general form here. We're going to have, that's fn of x, okay, equals the sum of, okay, equals the sum of the product of, let me clean this, l, okay, li of x, okay, multiplying f of what? Xi, where I starts from what? 0 and then ends at what? N. So this is the general form, the general form for the Lagrange interpolation function. So in this case, we know what our n is. We know that our n is equal to 1. So we are going to use the first order Lagrange interpolation polynomial as the question says. So we are going to have what f1 of what x. Then that will be equal to the sum of li of x, okay, multiplying what f of what xi, right, from I equals what 0 to what n, and then our n is 1 in this case. So rewriting this, we are going to have L naught of x, okay, multiplying what f of what x naught, right, because our first I will be 0, okay, and then plus, because you are dealing with sum, L1 of what x multiplying what f of what x1. Okay, so this will be the general first order Lagrange interpolation polynomial that you are going to use. So now that you have the general form, the main thing we have to do is to find the L naught of x and then the L1 of what x, and then we are finding the velocity at what time t equals what 16 seconds, right? And then from here we know that we will need what 2 data points, right? Because we're giving a first order, we said we should use a first order Lagrange polynomial. So we are going to add that to the one that's from here, from this expression. That tells us that you are going to need what 2 data points. And then we want to find the velocity at time t equals what 16. So we look at the data here and we look at where 16 falls into. So from here you can see that 16 falls within what 15 and then 20. So the data points you are going to use will be t naught equals 15, right, and then v of t will be equal to 362.78, okay, and then you're going to have t1 to be equal to 20, and then v of t1 will be equal to 517.35. Okay, so this is what you are going to have. Okay, so now let's go back to the general expression that I gave. Okay, I gave the general expression in terms of x and then f of what x. Okay, but from the table we were given t and then v of t. So let's rewrite this. So you're going to have v1 of t, okay, to be equal to L naught of what t multiplying what v of what t naught, okay, plus L1 of what x, sorry, I'm using x again, L1 of t multiplying what v of what t1. Okay, this is the general formula that we are supposed to use. Okay, so now we know what to do next, right? You have to find the weighing function. So let's look at that. So the general form of the weighing function is given as Li of what x, okay, that's equal to the product of what x minus what sj over si minus what xj, right, where j starts from what 0 and then ends at what n, but j cannot be equal to what I, right? This is what you have. Okay, so now we have two weighing functions here, which is what L naught of t and then L1 of what t, right? So now let's write it in the general form. For this case we are going to have Li, okay, we are going to have Li of t to be equal to the product of what t minus what tj, right, over ti minus what tj, right, where j starts from what 0 and then ends at what n. Our n in this case is 1, so it ends at what 1, and then j cannot be equal to what I, right? So let's take note of this. Okay, so now that's the general form that we have. So now let's find the weighing function. So the first one will be the L naught of what t, right, where I is equal to 0, and then you know that the possible j values are 0 and then 1, right, but j must not be equal to I. That means what the 0 is out. So let's look at the general form. So this will be equal to t, okay, this will be equal to t minus what tj. The only j value we have is 1, so that's what t minus t1 divided by ti, and then our I is 0, so that's what t naught minus what tj, which is what t1. Okay, so that will be the first one, and then the second one will be L1 of what t. In this case our I is equal to 1, and then the possible j values are 0 and then 1, and then j must not be equal to I, so this one will be out. So you are going to have this to be equal to t minus what tj. Our j is 0 divided by ti. I is 1 minus what? T 0. Okay, so this is what we have. Okay, so we know the data points we are using, right? We know what T naught is, and then we know what T1 is, right? So now let's do the substitution. So you're going to have T minus what? T1, which is what? 20, okay? Divided by T naught, which is 15, minus what? T1, which is what? 20. This is what you are going to have, okay? And then over here too, we have T minus what? T naught, which is 15, divided by T1, which is what? 20, minus what? T naught, 15. So this is what we have for the weighing functions, okay? So you can substitute this back into this general formula that we have here. And then don't forget, we know what V of T naught is, and then we know what V of what T1 2 is. Okay, so now let's do the substitution. Let me try and then get some more space. Okay, so now let's go back to the general formula that we have. We have V1 of T, okay, because you're using the first order Lagrange polynomial. Okay, so that will be equal to L naught of T, okay, multiplying what? V of what? T naught, okay, plus L1 of what? T, okay, multiplying what? V of what? T1, okay. So we know what V of T naught is, we know what V of what T1 is, and then we know what L naught of T is, and then L1 of what T2 is. Let's do the substitution. So for L naught of T, we have T minus 20 divided by 15 minus what? 20, right? This multiplying what? V of what? T naught, right? And then we know what V of T naught is. That's what? 362.78, right? So this plus L1 of T, which is T minus 15 divided by 20 minus 15, okay, multiplying V of what? T1, which is 517, okay, 0.35, okay. So when we do this, we are going to get the first order Lagrange polynomial, okay, but we've been asked to find the velocity at what time? T equals what? 16 seconds. Okay, so you just have to consider the general formula, then you substitute 16 in place of what? T. So let's find that V1 of 16 will be equal to, you're going to have 16 minus 20 divided by 15 minus what? 20, right? Multiplying 362, okay, point what? 78, right? Plus 16 minus 15, okay, divided by 20 minus what? 15, okay, multiplying 517.35. Okay, this is what we have. So let's simplify this and see what you're going to get for the velocity at time t equals what? 16 seconds. So you're going to have let's compute the first term, okay, at first. So you're going to have 60 minus 20 divided by 15 minus what? 20, right? This multiplying 362.78. So you're going to have 290.224 here. Okay, so let's see what you're going to get on the other side. So you have 16 minus 15 divided by 20 minus 15, okay, multiplying 517.35. So when you do this, you're going to have 103.47. Okay, so let's see what you're going to get for this. So 103.47 plus 290.224 will give us a value of 393.694 meters per second. So that will be the velocity value when time is what? 16 seconds. Okay, so this is how to apply the Lagrange interpolation method. Okay, so in a case, okay, let's say in a case where our n is equal to 2, okay, let's say our n is equal to 2, and then in that case you're going to have what? 2 plus 1 data points. Okay, so let's say you have a situation like this. Let's look at how you are going to tackle it. So I'll explain to you how you do in that case so that you use this same example to solve it. Okay, so now let's consider a situation whereby we have 3 data points. Okay, if we have 3 data points, then that means that what? Our n will be equal to what? 2. Okay, so in this case you are going to use a second order Lagrange polynomial. So you are going to have f2 of x, okay, to be equal to the sum of Li of x, okay, multiplying what? F of what? Xi, right? Where I starts from what? 0 and then ends at what? N, and then our n in this case is what? 2. So this is a general form that you are going to have. So now let's expand this. You are going to have f2 of x to be equal to our I values, okay, will be equal to 0, 1, and then 2. Let's take note of this. So you're going to have L0 of x, okay, multiplying what? F of what? X naught, plus the next I value, which is what? 1. That what? L1 of what? X, multiplying what? F of what? X1. And then the next I value will be what? 2. So you're going to have L2 of x, multiplying what? F of what? X2. So this will be the general Lagrange polynomial function, okay, when n is equal to what? 2. So our main goal now is to find the L0 of x, L1 of x, and then the L2 of what? X, right? So let's write the general formula for L of x. So we are going to have Li of x, okay, to be equal to the product of what? X minus what? Sj, right, over xi minus what? Sj, right, where j starts from 0 and then j must not be equal to what? I, but j will end at what? N, and then our n in this case is 2. So let me just put the 2 here straight forward. So our n is what? 2, right? So the possible j values are 0, 1, and what? 2. Those are the possible j values. But our I, okay, our I values changes, right? We have first L0, L1, and then what? L2, and then you know the sub values are the I, right? So in this case, our I values are also 0, 1, and then 2. Let's take note of that. So let's consider the first Li of x function. So we're going to have L0 of what? X, right? Because the first I value is what? 0. So for that one, we know that I is equal to 0, right? And then the possible values of j is 0, 1, and then 2. But j must not be equal to I, right? J must not be equal to I, and then our I is 0 in that case. That means what? We are going to cancel this j value, which is the 0. So the only possible j values that we have will be 1 and then 2. So let's continue. So let's find the L0 of what? X. It's a product, don't forget. So let's consider the first j value in this case. That's going to be 1, right? So you're going to have x minus what? Xj. The first j value is 1, so x1 over xi. Our I is 0, so you're going to have x naught minus what? X1 again. And then it's a product, so you're going to have times x minus what? Xj. What's the next s? What's the next j value? The next j value will be 2, so you're going to have x minus what? X2, okay, divided by what? X naught minus what? X2. So this will be for L naught of what? X. Okay, we are going to do same for L1 of x and then L2 of what? X. Okay, so let's take note of that. So you see that this is different from the previous one where we had just one of this, right? But in this case we are having 2. Okay, so that is confirmed from the definition I read from the beginning. So now let's find L1 of what? X. So in this case, our I is equal to 1, and then the possible j values are 0, 1, and then 2, right? But j must not be equal to I. So that means what? J must not be equal to what? 1, right? So we're going to cancel out this 1 from here. So the possible values of j are 0 and then 2. So let's find L1 of what? X. So you're going to have x minus what? Xj. The first j value will be 0, so that what? X naught divided by xi. Our I is 1, so that what? X1 minus what? X naught. Okay, multiplying. Okay, this symbol here means multiplication. Okay, so multiplying x minus the next j value, which will be 2, x2, okay, divided by x1 minus what? X2. So that will be L1 of what? X. Okay, so now let's find L2 of x also. So in this case, our I is equal to 2, and then the possible j values are 0, 1, and then 2. But j must not be equal to I. That means what? I must not be equal to what? Sorry, that means j must not be equal to 2 because our I is 2. So we're going to cancel out this. So the possible j values are just 0 and then 1. So let's look at that. You're going to have L2 of x to be equal to x minus what? Sj. The first j value is 0 divided by xi. Our I is 2 minus what? Sj, which is what? X0, right? Times the next, we are going to consider the next j value. So we're going to have x minus what? X1, because the next j value is 1 divided by x2 minus what? X1. So this is what you are going to have. So from here, you will substitute it back into the general function that we have. Okay, so let's go ahead and then do that. So we are going to have f2 of x. Okay, let me use the red marker to write this. This will be equal to L naught of x. Okay, so now let's look at what you are going to do. Okay, let me use the red color. So now we know our L naught of x, which is what you have here. So let's substitute it. So you're going to have, I think I should use big brackets. Okay, let me use square brackets. So you're going to have x minus what? X1. Okay, divided by x naught minus what? X1, right? Bracket closed. This multiplying x minus x2. Okay, divided by x naught minus what? X2, right? So that's just our L naught of x. Okay, so you're going to multiply by what? The f of what? X naught, right? So let me write this down. Multiplying what? F of what? X naught. Okay, so don't forget all the values will be known, okay, based on the question, but it's only the x that will not be known. Okay, so you have this here. Okay, so this plus, right, L1 of what? X, right? You know our L1 of x, so let's bring that also in. So you're going to have this to be x minus what? X naught divided by x1 minus what? X naught. Okay, this multiplying x minus what? X2 divided by x1 minus what? X2, right? So all this will be multiplying, what? F of what? X1. Okay, so let's do that. Let me bring it here, times what? F of what? X1. I don't have much space there. So plus, okay, so plus, let's look at L2 of what? X. That's what we have here. Okay, so now let's do the substitution. Okay, so for that one also, we have L2 of x. We have x minus x naught, okay, divided by x2 minus what? X naught. Okay, all this multiplying x minus what? X1 divided by x2 minus what? X1, right? Brackets close. All this multiplying what? F of what? X2. Okay, so when you do this substitution, then you're going to get the second order Lagrange polynomial. Okay, so you can apply the question that we solved previously. So let me try and then get the data so that we can solve it. Okay, so these are the data points. Okay, and then from the previous question, we used a first order Lagrange polynomial, but in this case, we're using a second order Lagrange polynomial. So let's look at how you're going to solve this. So I have the general formula here, just that in this case, the question we're giving the values in terms of t and then v of t. So you just have to rewrite the general formula here. Okay, so let me try and rewrite it. Okay, so I've written the general function, okay, in terms of what? T. So that's what we have here. So let's write down the values that we know. Okay, let's look at that. So let's consider from time t equals 10 to 20. Okay, let's consider this. So we are going to have t naught to be equal to 10, and then v of what? T naught to be equal to 227.04. Okay, and then you're going to have t1 to be equal to 15, and then v of what? T1 to be equal to 362.78. Okay, and then you're going to have t2 to be equal to 20, and then v of t2 that will be equal to 517.35. So those are the data you have from the question. So now let's substitute into the general formula. And then mind you, we are finding out what t equals what? 16 seconds, right? So we are finding out what t equals what? 16 seconds. So our t will be 16. So let's do the substitution. Okay. Alright, so you're going to have v2 of 16, right? So you're going to have the product of what? T minus t1, that will be 16 minus what? 15, right? divided by t naught, which is 10, minus what, t1, which is what, 15. Okay, this looks a little confusing to me. Okay, but let's continue. So minus 16 minus t2, which is 20, okay, divided by t naught, which is 10, minus what, 20, right? Bracket close. All this multiplying what, v of t naught, which is what, 227.04. Okay, this is what you have. Okay, so plus, let's consider the next term. We have t, which is 16 minus what, 10, right? Divided by t1 minus what, t naught, which will be 15 minus what, t1 is 15, t naught is 10, so 15 minus what, 10. Okay, multiplying t, which is 16 minus what, t2, which is 20, divided by t1, okay, which is what, 15 minus what, t2, 20. Okay, this is what you have. So all this multiplying v of what, t1, which was 362.78. Okay, so all this plus, let's consider the last term. So we have bracket open t minus t naught, which will be 16 minus 10, divided by t2, which will be 20 minus 10. Okay, multiplying 16 minus 15, okay, divided by 20 minus what, 15, right? All this multiplying what, v of what, t2, which is 517.35. Okay, this is what we have. So let's sum up everything and see what you're going to get for the velocity at what, 16 seconds. Okay, so now let's look at that. So let's consider everything we have here. Okay, so let me punch everything at once. We have 16 minus 15 divided by 10 minus 15, multiplying 16 minus 20 divided by 10 minus what, 20. All this being multiplied by 227.04. Okay, let's see what you are going to get. So we have a value of minus 18, okay, 0.1632. okay, 1632. Okay, so let's see what you're going to get for the second term also. You have 16 minus 10 divided by 15 minus 10, multiplying 16 minus 20 divided by 15 minus 20. All this being multiplied by 362.78. So for that also we have plus 348.269. Okay, let me write 0.2688. Let me write it this way. Let's look at the last term. For that one also, we are going to have 16 minus 10 divided by 20 minus 10. Okay, multiplying 16 minus 15 divided by 20 minus 15. Okay, all this being multiplied by 517.35. So you're going to get plus 62.082. So let's sum up everything and see what you're going to get. So you have minus 18.1632 plus 348.2688 plus 62.082. Okay, so let me run this to 3 decimal places. So this will give us a value of 392.188 meters per second. So that will be the velocity when time is what, 16 seconds. So this is another way, okay, to use the Lagrange polynomial to solve this type of question. In the previous question we used a first order Lagrange polynomial, and then the second one we used what, second order. So you can try third order, fourth order, and so on.